Hello and welcome to Python Programming for Beginners. In this video, we will solve a challenge using Karel the Robot. Let me tell you a little about myself. My name is Devraj Agarwal. I'm an experienced software professional with 25 years of expertise in building and managing applications across consulting, finance, and various other industries. If you're looking to dive deeper and learn the complete fundamentals of Python, I recommend checking out my Python's beginners course on Udemy. This course offers easy to follow lessons along with quizzes, exercises, and solutions to help reinforce your learning. The course link is shown here and in the video description below. If you have not watched other parts in Learning with Karel the Robot series, I highly recommend you to view them first. Links for other videos are in the description. Here is a quick introduction from part 1. Karel the Robot is a simple robot that lives in a grid-like world. In Karel's world, there are 4 basic directions: north, south, east, and west. Karel can move one step at a time in any of these directions, but it can't walk through walls. Walls are barriers that Karel must navigate around. In addition to walls, there are objects called beepers, which Karel can pick up and put down. Karel knows just 4 basic commands: move, turn left, pick beeper, and put beeper. Using these simple commands, you will learn how to control Karel and solve problems within its world. In this task, Karel has to walk through the first row of the grid and double the number of beepers on each corner where beepers are present. For example, if a corner has 3 beepers, Karel should add 3 more to make it 6. Let's go to PyCharm. Here we have a Python file double beeper solution with code to load the initial state, double beepers start, and a few helper functions from previous videos. You can find these words and the solution in my GitHub repository. Let's decompose the problem first. Step 1 is to move across the first row. In step 2, Karel doubles the beepers if it finds beepers on a corner. Finally, Karel returns home. To move across the first row, let's write the while loop to move Karel to the southeast corner. Run the program. While moving across the row, Karel checks for a beeper and takes action to double them. So let's move step 2 under step 1. The code to check beeper is if beepers present, double beepers. First, think of a strategy to double the beepers. We don't know the exact number of beepers on a corner. It can be 1 or many. We can't use variables to remember the count. With limited functions available to Karel, what options do we have? Let me give you a hint. Pick all beepers from a corner and put them somewhere else. Now pause the video and think how you can solve this task. Our strategy is to pick all beepers and put it at a nearby corner and then put all of them back. The only difference is that while putting back, we put 2 at a time instead of 1. This way we can double the beepers without counting. Next, we have to decide where to put those beepers. The logical answer would be a step up in the second row. We can't put them in the first row. In the current world, we know that the corners on either side of the currently occupied corners are empty. And you would be fine if placing the beepers on either side. But if you are given a different state, we can't be certain. So it's safer to put them in the second row just above the corner we are going to work on. Let's write the code. Since we can't be certain about the number of beepers, we are going to use a while loop, and the condition is to continue until beepers are present. So first we pick beeper and then we move up. To move up, first we turn left and then move. Next, put down beeper. Now turn around. We are going to use the helper function to turn around. Then we move to the first row and finally we turn left. Why are we turning left? If you check the precondition in the while loop, Karel is facing east. If we don't turn left in the next while loop, when the turn left function is called, Karel will face east instead of north and the process will fail. We should now run the program. Well, it works as expected. Before moving forward, let's convert the code to double beepers in a separate function. We call the function double beepers here. We're also going to write some helper functions to move up and move down. Move up, take these two lines of code from here, put it here, and replace this with move up, and we create move down function. And then we take these three lines of code from here, put it here, and replace this with move down function. Okay, before moving forward, let's reset and run the program. Okay, so it's working as before. So we have completed the task to move beepers to the row above. Let's add a comment here so we know exactly what we are doing. Move beepers to the row above. Next, we move back to the second row. We come out of the while loop and write a move up command. But before that, let's add a comment. Move to the row above. We use move up command. After moving up, now we have to move all the beepers back to the first row. Move all beepers back to the first row. We again use the while beepers present loop. First, we pick beeper, then move down. Now we have to put beeper. We will be putting two beepers for each beeper we pick in order to double them. Then we move up to process the next beeper if present. If there is no beeper, the while loop's condition will return false and we will exit the loop. Let's run the program. Oh, Karel went all the way up. Let's check the code. In double beepers function, after moving the last beeper from row 2 to row 1, Karel went back up to row 2 facing north. At this point, the while front is clear function in the main loop is still running, which has the move command getting executed. This moved Karel to the top. To fix this, it is important to move Karel back to the first row after doubling the beepers so that Karel can move forward towards east instead of north. We add a comment, return to the first row, add move down command and run it again. Perfect. Karel has doubled all the beepers and is now on southeast corner. It has to go home now. We already have a go home function from previous sessions. Let's add the go home command to the main function. We run the program again. We achieved the end state successfully. This completes our task. Thank you.